Okay, Brad. So I see you want to talk a little bit about dynamic multipathing, or DMP. Can you tell us how it works?
Absolutely.
Okay.
So let's first look at a very simple but typical customer scenario. Right? They've got a server with a couple of HBAs or host bus adapters. They've got a single switch, and they've got an array with a couple of controllers. Right? And again, this is overly simple, right? But it serves the point. Okay? So if we hook everything up, and again, we'll keep it simple. Now, if we look at what are the paths to get to the different LUNs that are being zoned out from that array to this server, it would look like this. Okay. So in this simple example, we've got 4 paths to each LUN. Let's look at it from a little different perspective. All right, let's say that we're zoning out 2 LUNs. So if we look at it from, say, DMP's perspective, what we really see is that again, using this topology, there are 4 different paths to each LUN. Okay? Now, OSs by default are not multipath aware. Right? So each of these paths corresponds to an OS device file. From the OS's perspective, they see 8 disks. Right? When DMP goes through its device discovery process, which is one of the key things that DMP does, usually at boot time or at initial volume manager starting up time, it goes through each of these paths, does a SCSI inquiry, and realizes, oh, this is just 1 disk with 4 paths. So the end result of those 8 disks is really 2 disks with 4 paths each. Right? So device discovery is a key part of DMP. The other part of DMP is associated with the actual I/O. If you look at the I/O path, it really is like this. The application, and that might be VXFS, sends a request to Volume Manager. Volume Manager figures out what part of the volume they're asking for, sends that on to DMP. DMP is the one that's responsible for knowing the OS device files, sends the appropriate OS device file, gets that down to the SAN, the data gets returned. When DMP does that, it's responsible for handling these paths. So DMP decides which path to go down. For example, if this is an active-passive LUN from an active-passive array, it can only go down 1 path at a time. If, for example, this is an active-active, a LUN from an active-active array, it could theoretically send down all 4 paths at the same time. Okay? So DMP manages those paths, and the other key part of DMP is handling error situations. So let's say that this path fails for some reason. DMP is going to select another path to go down. If all the paths fail, DMP would actually fail the I/O back to Volume Manager. So device discovery, handling the I/Os, and error detection are the 3 key parts of DMP.
Fantastic. So really, it does more than just handling I/O. It does the device discovery as well. So even in these situations where the customer might lose a path, it knows to be able to handle that path and send more I/O down.
Absolutely, and probably unbeknownst to the customer that it's doing that.
Which is great. Yeah. That's what our customers want. Yeah. So thanks a lot, Brad, for explaining how the basics of DMP actually work. We appreciate it.